Okay, I like to talk about food and food systems. So I want to just practice using some of the vocabulary that I've just been talking about more or less in the abstract. I want to go through some food system examples of that. So we have food systems made up of producers, preparers, packagers, distributed consumers, regulators. Those are the elements of the food system. The relationships or energy of the food system includes money, it includes climate, it includes fossil fuels to different extents. And it has emergent properties such as quality. Quality could be an emergent property of a good set of producers and good regulatory policies. Risk is an element of a food system, as so is security. Those are system properties. So we already have elements, we have relationships, we have emergent properties, and we have sorry, I should have said the purpose of the food system is to grow, distribute, provide food to people. In terms of energy and entropy, we have both metaphorical and physical energy involved in the food system. We have sunlight and fossil fuels. We have metaphorical energy like money, like time and attention, care, levels of service, those kinds of energies. There's also profit, hunger, status, those kinds of energies. And in terms of the food system, entropy can come from physical things like spoilage. It can come from disruptions to the food system like supply chain disruptions. Or it could come from changes in fashion or trend. So for example, maybe avocado toast stops being a staple food of a certain social group. And the demand for avocado toast and the associated revenue goes down, and avocado farmers, some portion of avocado farmers have to do something else. So what about the properties of risk and resilience in the food system? Some of the more romantic writings on sustainability and resilience talk about a really highly localized food system. So to look for examples of highly localized food systems, you would look to, I think, the feudal settlements and earlier feudal settlements of the Middle Ages, highly localized. So if you have a bad weather event, you have a crop failure one year, things are pretty thin. So an entire area production could be wiped out. 2 years ago, she said, looking out the window, depressed, 2 years ago, our wildfire smoke was so bad that the gardens were all affected because there wasn't enough sunshine making it to the ground to really do the sunshine crops. So radically localized food systems are going to have a level of risk. Even if they're indoors, then you could have a fire risk. And highly centralized or industrial food systems have different kinds of risk: contamination risk, supply chain risk. And I'm going to talk about a peanut butter example, although we keep hearing about romaine lettuce recalls across vast geographic areas. So current urban food systems are highly reliant on distribution networks. I think most cities have something like 2 to 3 days food supply. So then if you have a disturbance like a pandemic or a hurricane or something in the supply chain, it can quite rapidly result in food shortages. So I really like this peanut butter example. It's from a few years ago now. Gosh, it's probably from 15 years ago. And it's from the US, but you know, peanut butter, of course, it's from Georgia. The Peanut Corporation of America in Blakely, Georgia, which is a ginormous peanut processing facility, in a highly centralized, highly industrialized food system, right? It had the testing that was required from the US Food and Drug Administration requires most of those large-scale corporations to self-monitor through testing, and they were doing that, and they tested and they found salmonella in a giant whack of peanut butter processing. And they didn't stop that shipment in response to those results, which they're supposed to do. But the testing meant that they knew that they were shipping peanut paste that was contaminated with salmonella. 9 people died. Hundreds of people were ill. And then it was tracked down through public health channels, and there was a recall. And the number and variety and geographic extent of the recall was just, it was breathtaking. Cakes and pies and brownies and candy and cookies and crackers and donut and dressings and all kinds of things have this peanut paste in them. You think there's all those Vietnamese salad dressings, right? So in that system, and one of the things, if you think about the last lecture, I was talking, is it a disturbance or isn't it? Is the salmonella outbreak in this case, is it a disturbance? Or is it kind of a somewhat regular and predictable part of the system, and we have a feedback, a loop about it, we kind of expect it to happen, and so we take care of it, and then it's not a disturbance, it's just part of the way the system works. So I'm going to get to my beautiful artwork here. One thing we do know from the scale of how many people died and how many gazillions of products were recalled, we know that this as a scale of operation, the Peanut Butter Corporation, the Peanut Corporation of Blakely, Georgia, that one facility, it was really essential. I think it was about a half of the peanuts in the US went through there. Maybe it was just a third, but it's a massive proportion through one facility, which means, and when you have everything going through a single point, you have an inherently vulnerable system. I mean, what if terrorists were to attack the Peanut Corporation of Blakely, Georgia? Think of how many things from Cliff Bars to peanut butter we wouldn't have. Don't imagine they thought of it, but you could really wreak havoc on North American society by affecting this one single factory. So it's clearly a vulnerable system as a property. Was the salmonella outbreak a disturbance? Well, yeah, it was a disturbance in the sense that for a while it broke the peanut butter paste distribution and system broke. So in that sense, it was a disturbance. I think it's also useful to think of what kind of failure it was within the system, because you remember the system was already designed with that what if, you know, you need to test for salmonella and various other diseases, because these are the kinds of things that happen in food processing, and so that loop was in there. So in that sense, you could very usefully think of that as a failure of one of the feedback loops in the system, because just the very scale of the system itself, the massive quantity that's in that one facility, means that you're going to feel there's going to be a lot of energy behind not throwing a mountain of peanut butter away. And so in that sense, that highly centralized thing increases the cost for that one manager to say, no, we need to throw all this stuff away. So while there is that system feedback of testing and regulatory oversight, the system also has the motivations within it for that not to work. So then that allows you, looking at it that way, allows you to look at how the regulatory system works within the system. But I think that's a really good example of something that, it's useful in some ways to think of it as a disturbance because it broke the system. And so you can think, well, how might we have a more resilient peanut butter system? But it's also useful to think about how, like within the system, how could we be making peanut butter safer? Okay, so that was my example of most of the words that I had used in the prior two sections. I have one more lecture, which I'll return shortly to do.